Good morning, everybody. My name is Helmut Katzgraber. I'm a senior practice manager at the Quantum Solutions Lab at AWS. And I'm here with my colleague, Andre Luckow.
Yeah, hello, my name is Andre Luckow. I'm responsible for emerging technologies at the BMW Group IT.
Yes, and I'd like to pass it to him. He will start. At some point, I'll take over and finish the presentation. Please.
All right. So today we are here to talk a bit about quantum applications in the automotive industry, right? And most importantly, about our BMW Quantum Challenge that we initiated together with AWS. But before we get to the announcements of the winner of the Quantum Challenge, right, we need to slowly start. And we would like to give you a brief overview about why is BMW investing in quantum computing and what are the challenges that we see with adopting this technology in industry. Then Helmut will speak a bit about our partnership with AWS and how we work with AWS on identifying the right use cases, at investigating those use cases, also, getting some benefits for our businesses before we reach the real quantum advantage. And last but not least, right, the most important part, we will announce the winners of the Quantum Computing Challenge. Wrong direction. All right, quantum computing at BMW. As you probably know, the automotive industry is a very complex industry, right? We do have plenty of optimizations, machine learning, and simulation problems, right? Just to give you some numbers there, the BMW Group builds roughly 10,000 vehicles per day, right? And those are built in 31 international production plants, right? And in order to do so, you have to ship millions of parts across the planet. And needless to say, there are ample of opportunities for optimization and machine learning in that area. The second domain, right? Chemistry simulations. Also, right, everything that you can investigate in a simulation environment before you have to build the actual component or the battery, right? It saves costs, and most importantly, it enables us to build better products. Last but not least, numerical simulations, right? The BMW Group operates a significant high-performance computing infrastructure, right? And on those machines, we have numerical simulations for everything, right? Aerodynamics, crash are the most well-known ones, but obviously we also have simulations, for example, in the production environment. And that was also one specific challenge that we asked the community to generate ideas on in the Quantum Challenge. So how are we approaching that topic? You have the value chain there. You have the research development. We have to manage our supply chain. We have production. We need to sell the vehicle. We need to finance the vehicle. Our vehicles are nowadays always on. They are always connected, meaning we'll provide a broad set of services surrounding that vehicle. In every one of those areas, we identified critical use cases, right? And maybe let me cite William Oliver here from 2 days ago, right? What are the key criteria here is the use cases need to be computational intensive, right? We are running into limits with our current approach. There needs to be a promising approach, for applying quantum to that use case. And most of all, it needs to be a useful problem, right? If we are addressing that problem, we have a broad impact on not only our business, but maybe on the entire automotive or in the other kinds of industrial applications. So how do we work with that community? BMW is a founding member of the Quantum Technology and Application Consortia, which might not be very well known in this audience here, but it's a German group of 10 plus industry players in Germany, including BASF, Volkswagen and others that came together in order to advance quantum computing from the application perspective. And our mission is to work with academia and with industry partners to bring the ecosystem forward. Needless to say, today we are specifically talking about our collaboration also with AWS, because needless to say, they are one of the key players in that area, and we benefit a lot from their expertise, both on the algorithmic side, but also on the Bracket side of things. We do have some research collaborations. We just announced 2 endowed professorships in Germany, one at the Technical University in Munich and one at the University in Aachen. And the ecosystem, our Open Innovation Challenge is one way really to bring together all those different elements and get people thinking about automotive application to all our benefits, hopefully. So, talking a bit about the quantum computing challenge we did, and you can also go to BMW Crowd Innovation there. We identified 4 reference problems, right, that we basically specified in a paper and pencil way of things, right? So we have a high-level description of the problem. We have some real BMW data that the participants were able to use, and by the way, is still online. So yeah, if you're interested in kind of learning more about the problems and the complexity of those problems, you can go to crowdinnovation.bmwgroup.com and learn more about that. So we have the sensor position optimization problem, which is basically a generative design challenge, right? How can you integrate different types of sensors into the vehicle? We have the pre-production vehicle configuration problem. And this is just one representative problem of many of those kind of configuration problems. But of course, as I said, you have a vehicle, you have many components, you have many options. I'm not sure when the last time is you configured the vehicle. But there are many options you can provide your vehicle. And obviously, before you ship that to the customer, you need to make sure that every combination that you can build is also sound and passes all the tests. We talk a bit about the material deformation problem, right, which is one of those numerical simulation problems there. And we also added one of the machine learning AI problems with the automated quality assessment. So about the challenge, right, we were very, very pleased with the results, right? It was great to see such a big resonance, right? And we had 70 final submissions from all over the planet, and those were all high quality submissions. So thank you everyone who participated. We know you spent a lot of effort in preparing those submissions, and really appreciate that because we learned a lot from that, right? We had submissions from all over the world there. I mean, there's a slight bias toward Europe, but that's not bad. The most submissions we received for the AI problem, the automated quality assessment. The second one was the pre-production vehicle configuration problem, and the sensor positioning optimization and material deformation problems. We do realize that those are the most complex problems that we had in the challenge. We had a few submissions. But with that, I would hand it over to Helmut, who will tell us a bit more about Quantum Solution Lab and how to approach quantum use cases.
Thank you, Andre. So I'd like to take over here and tell you a little bit about the challenge, the selection criteria, but also about the use cases that we are seeing currently in the automotive industry. Oh, wrong button. This thing is backwards. So let me remind you about the main goals of the quantum computing challenge. First and foremost, the idea was to discover potential quantum computing solutions for real-world use cases in the automotive industry. Now, in parallel to this, one important aspect was to make sure that these actually are implementable, meaning that can we run them on Amazon Bracket? Now, the Quantum Solutions Lab partnered with the BMW team to actually design the challenge, build it from the ground up, identify the use cases, and more importantly, assess the submissions. As you might imagine, this was a lot of work. As Andre said, we received a lot of submissions, some which were very extensive. It was a fun read, many nights. And more importantly, we learned a heck of a lot of it. So once we had these submissions, we went through round 1. Then in round 2, where we selected a smaller subset of submissions, we asked the participants to actually leverage our quantum computing service, Amazon Bracket. And Amazon Bracket is a fully managed quantum computing service that is designed to help you speed up your scientific innovation. You can build your solutions either via Jupyter Notebooks, the Amazon console, or the AWS console, or any other development environment. And not only that, but you're leveraging all the benefits of the cloud, meaning that you're not just focusing on using quantum hardware, but you can do an end-to-end pipeline, for example, from data ingestion to manipulation to running it, to testing, and more importantly, also running it on quantum hardware and then visualizing your results. In order to test the submissions, you can use any of our simulators. We have a local simulator, as well as 3 fully managed simulators in the cloud. One of them is a state vector simulator, the other one is a tensor network simulator, and the third one is a density matrix simulator. Once you're satisfied with your test, you can actually run it on one of our quantum backends, where we have devices by D-Wave, IonQ, as well as Rigetti, and as was recently announced, soon we will be seeing devices by QERA and Oxford Quantum Computing. And as I said, the beautiful thing about Bracket is that it's fully integrated in AWS's cloud, meaning from security to identity management to all the nice aspects that you get from AWS, you can leverage them for your quantum solutions. You can analyze your results, you can visualize them, and at the end, basically look at what you have developed. And we've had some amazing submissions that have leveraged a lot of very interesting tools. Now, this is a little bit more the AWS side of the story. And this is what we are typically seeing when we are discussing with companies in the automotive space. And as you can see here, automotive has many use cases that span across many, many domains. Before I go through these in a little bit more detail, let me just explain to you what you're looking at. You see those little colorful boxes, and on the top right of the slide, you can see a legend. The first column represents a solution that you would typically run using high-performance computing. Think of finite element simulation, something like that. It's something that is natively HPC. The second column is a column where you typically would leverage machine learning solutions today. The third one would require a fault-tolerant quantum computer in an ideal case. And the fourth one that we labeled as NIO, we are basically thinking about tools and techniques that we have developed from our study of quantum computing to run today on scalable hardware. And NIO stands for Nature-Inspired Optimization. Commonly in the community, it's called Quantum-Inspired Optimization. However, we think that that term is too narrow. It needs to be broadened. Now, from the manufacturing point of view, as you can see, there's many problems out there. You can also see very nicely that a lot of those can be tackled with a native fault-tolerant device down the road. And this is good news because it means that we need to start looking at these today so that once the hardware catches up, we can actually just flick a switch or change a line in our codes and then run them on a quantum backend. And there, the most prominent and typical ones that we see are job shop scheduling, factory line optimization, robot motion planning, and predictive maintenance. Chemistry and simulation is also key to the auto industry, especially now that electric vehicles are nascent. There has to be a lot of work to be done in the chemistry of batteries and their design. Similarly, also looking at different materials, example being through molecular similarity. Catalyst discovery is key. And then, of course, also the use of finite element simulations, as Andre said, as one of the bigger HPC-type challenges out there. Logistics, transportation, and routing is another important area. It pretty much affects any industry, but also, of course, the automotive industry, from capacitated vehicle routing, last, middle mile, first mile, something that Amazon champions, vehicle fleet optimization, and then traffic flow optimization. Finally, and this is something that's sometimes very often forgotten, finance also plays a key role in automotive as well as many other industries. And by the way, as a side comment, when you look at this, you see that finance has a lot of colorful little boxes. And the reason is that financial institutions are really being trailblazers when it comes to quantum computing, as well as BMW. So it's true. So basically, things like portfolio optimization, I think we've all heard this use case at one point, okay? Risk analysis, derivatives pricing, and fraud detection. So we're working on tools that leverage quantum devices to actually tackle these problems today. Now let me switch gears and give you a brief reminder as to what the criteria were that we used to evaluate the submissions in the challenge. First and foremost, as I said before, we want to find the most mature solutions with the most future impact. And we evaluated all submissions with 5 main criteria. Number 1, comprehensibility and theoretical foundation. Basically, when we get something to read, we want to be able to understand it. And this is really important. Okay, we want to make sure that this is built on solid theoretical grounds. Another important one is, of course, the value to the automotive industry. Implementation is also key. This is where Bracket comes into the picture. We want to see if you can leverage currently existing tools on Amazon Bracket to actually solve these problems. Scalability is another important aspect. We want to make sure that while we are developing today, for example, for NISC hardware, this will actually scale once the devices evolve. And then finally, and most importantly, innovation. The idea really is to come up with the most brilliant solutions to very hard problems. With this, I'd like to move on now to announce the first two winners of the challenge before I pass it to my colleague, Andrei Luckow. Let's look at the first submission, and this is the sensor positioning problem. As Andrei said, the goal is to find an optimal selection of sensors. One second. To actually cover the vehicle with the constraints of cost and regulation. And the winner is Accenture. Congratulations, Accenture team. Now we prepared Accenture prepared a little video that we'd like to share with you today. Except there's no audio. Which is a bummer because the audio is precious. So since I can see a couple of faces from the Accenture team, maybe you guys want to come up here for a few seconds just to say hi. Congratulations.
Thank you very much.
I'm just gonna.
Yeah.
Oh,
Oh, thank you very much. Thank you.
Thank you.
Thanks.
Good. Congratulations again. Let's move to the next use case. And this is the pre-production vehicle configuration. As Andrei said, this is a tough problem. You have to build some vehicles for pre-production, and you want to make sure that you can do all the necessary tests. And as you can imagine, this is a nasty, horrible constraint satisfaction problem. Now, the winners for the pre-production vehicle configuration are 1-qubit entity. Congratulations. Any members of the 1-qubit team here? Oh, cool. So we also have a video, and I hope that the audio is going to work this time. Which would be very unfortunate if it doesn't. But it doesn't look like it. Oh. I don't use Windows. Maybe I shouldn't touch this. Yeah, please come on stage. So unfortunately, as I said, we don't have audio. So I might as well just...
Yeah, thank you very much.
Thank you so much.
Thanks so
Thank you.
much. Thank you very much. Thank you.
Thank you.
Thank you.
Oh, so your turn.
All right. So now we are coming to one of the famous numerical simulation problems, material deformation. Here the winner is, right, make sure that I press it in the right direction. Q&Co, Vincent Elving, Benno Preur, Annie Payne, and Alexander Kirenko. So specifically, the winner team provided the differential quantum circuit, right? So a very promising approach to solve those kind of, linear equations on a near-term device. So very excited. So also here we do have a video, but probably we don't have any sound, right? But I let you, unfortunately, right? Okay. Do we have someone from Q&Co here? No. Okay. So then we come to the final category, the automated quality inspection use case, right? As you can imagine, I think in the beginning, I didn't say too much about that use case. Nowadays, we do have a lot of cameras and visual inspection devices in our manufacturing facilities, right? Just to ensure, that we always have a very consistent quality before the product leaves the vehicle and leaves the vehicle to the customer. And we specifically investigated two different data sets here, right? One on a Kaggle and one Kaggle data set and one BMW internal data set. We saw tons of solutions here, and they were all very good, right? Some used the variation methods, some used quantum computing for augmenting data, and the third category was basically using quantum computing to accelerate the linear algebra calculations that are necessary to run, for example, convolutional neural networks. And the winner team did exactly that, right? The QCVR team from Paris, basically, congratulations, right? Used linear algebra operations to accelerate and also improve the quality, most importantly, of those networks. Do we have anyone from QCVR here? Thank you.
Hello Q2B, we are the QCVR Paris team, and we are happy to share with you our result for the BMW challenge on automated quality assessment. Classically, image processing problems are solved using convolutional neural networks. We have proposed 3 new quantum algorithms for near-term devices. They are based on provable linear algebra to implement a faster convolutional product. Our numerical simulations show the similar or sometimes better trainability for the quantum CNN compared to the classical one. Next, continue this research with real quantum hardware.
So congratulations to QCVR, and while we have sound and we still have some minutes, right? Let's watch the other videos because they are so great. And I know you guys spend a lot of effort in preparing the video. Happy quantum engineers. So,
we are one qubit entity, a consortium that combines the world's leading minds in quantum algorithms, physics, and industry consulting.
One qubit provides the algorithmic research and engineering, while entity research advances the capabilities of non-classical computing, and entity data combines the technology with business acumen. Our main submission is a hybrid approach using custom quantum-inspired solvers that natively solve the problem and is ready to integrate gate model quantum capabilities as they mature.
We are one qubit entity. We are one.
So,
hi everyone at Q2B. My name is Vincent Elving from Q&Co. We're very honored to be selected by BMW to win this challenge on material deformation in production. And we targeted this with the differentiable quantum circuits algorithm. We found some early promising results, and we hope to continue in 2022. Shout out also to the team at the University of Exeter who worked on the early versions of this algorithm. And we thank BMW and AWS for the opportunity. and wish everyone happy holidays and a good new year.
All right. So congratulations again to all the winners of the challenge. And thank you everyone who participated in the challenge. Let's wrap this up. I think it's important for all of us, and I guess, I'm preaching to the choir here, right? We're all excited about quantum computing and how can we take the next steps in our fields, in our industries with quantum computing. Where's the business value? What problems can quantum solve, right? How are we going to approach this? There's not a single person who can do it all, right? We need to work together across companies, across countries, right? To build up a collaborative ecosystem, right? And obviously that's what we wanted to achieve here with the Open Innovation Challenge. What I also want to highlight, right? This is not the end. This is the beginning, right? So BMW committed to work with all the 4 winner companies, right, next year, and to basically bring that project to the next level and utilize the momentum that we achieved with the Quantum Computing Challenge, right? And again, thank you very much to everyone who participated. Thank you very much to AWS. Also, thank you to all the people that you don't see here on stage. We have Elvira and Johannes from the BMW team here. We do have, many people at BMW and AWS side who read through all the proposals. We had external professors at the Technical University of Munich who reviewed all the proposals. So thank you to everyone there.
Yes. Thanks, everybody.